Welcome back, guys. Now, hopefully you've watched the first video already. And in that video, we were working out a moment. And a lot of the time you'd have seen one force acting at a pivot. So now what we're going to do is look at scenarios where you've got maybe two forces acting. Now, when you've got two forces acting, what you want to do is work out what's happening overall. And that's called the resultant moment. And a good place to start thinking about this is maybe on like a seesaw. But before that, a quick definition for a resultant moment. So it's given by the sum of all moments acting on a body. So as I said, we can think about this using a seesaw. So here we go, we've got a seesaw, very, very simple. We've got a bear on one side, a man on one side. Now the bear obviously is a little bit heavier. He's got a greater weight. His weight is 200 newtons. The man is only 100 newtons. So naturally what we think is that the bear is going to tip the seesaw downwards. So let's have a look by using some moments. Now from the first video, hopefully you've also learned that an anti-clockwise moment is generally given a positive sign and a clockwise moment is generally given a negative sign. So for the bear, again, hopefully from the first video, you'll be able to tell that the bear is going to create an anti-clockwise moment as he's going to tip the seesaw down that way there. So to work out the moment for the bear, we would need to, quick reminder, the formula for a moment is the force times the perpendicular distance from the pivot. Make sure you remember that. So the pivot point is obviously this bit in the middle. So I'll just highlight that in blue there. And now the distance of the bear from the pivot is 6 meters. So to work out the moment created by the bear, we would just do the force, which is 200 newtons, times by 6 meters. And that's going to give us 1,200 Newton meters. Now, because that's in the anti-clockwise direction, I'll leave it like that. You can put a positive sign next to it if you wanted to. So we can put it as positive 1200 Newton meters. So like that. Now, let's have a look at the clockwise direction. Now, the man is going to be creating a clockwise moment, and his force there is 100 newtons. So that's going to be 100 newtons times by 6 meters. And so overall, we've got a moment in the clockwise direction of 600 Newton meters. Now, because that's a clockwise direction, we'd put a negative sign in front of it. So negative 600 Newton meters. There we go. Now we've worked out our two moments. There we go. We've got 1,200 and minus 600 Newton meters. Now, what did we say? We said that resultant moment, so the overall effect, is given by the sum of all moments acting on a body. So now all we're going to do is just add these two moments together. So we've got positive 1,200 Newton meters, and we've got negative 600 Newton meters. And overall, what you can see is this is going to come out as 600 Newton meters. But the important thing is that this has come out as a positive 600 Newton meters. Now, what does that mean? Well, if we refer back to the start, where we put a little positive sign on top of the anti-clockwise, that was to tell us that everything in the anti-clockwise direction will be positive. So what that means is that this here indicates that the resultant moment is 600 newtons in the anti-clockwise direction, meaning that the bear is going to tip the seesaw downwards. Now let's have a look at another example where the bear maybe comes a little bit closer this time. So you can see the bear is only 3 meters away from the pivot point this time. So we'll start the same way again. Let's put maybe anti-clockwise down. And remember, anti-clockwise is given a positive sign. And then we'll go with clockwise. And clockwise is going to be given a negative sign. Just like that. Now this time, the moment created by the bear is going to be 200 newtons multiplied by 3 meters. This time that's going to give us 600 Newton meters. And because that's in the anti-clockwise direction, that's just positive 600 Newton meters. I'll leave that there. And now for the man. So the man is going to be 100 Newton meters, multiply that by 6 meters. So also 600 Newton meters. And let's put a negative sign in front of it because that is the clockwise direction. Now to find our resultant moment, all we do, add these together. And hopefully what you can see straight away is that if we're adding these together, so positive 600 Newton meters and negative 600 Newton meters, overall we're going to come out with 0 Newton meters. Now, what does this mean? Well, this means that the seesaw is going to stay completely level. And that's because the bear and the man are both producing the same moment. Now bring the bear closer again. So now you can see the bear is only 1 meter away from the pivot point. So there's our pivot point again. There you go, the bear's just 1 meter away. And let's again put anti-clockwise. And anti-clockwise is positive, and clockwise, and that's going to be negative. So we start with the bear, this time 1 meter. So it's going to be 200 newtons, and we'll times that by 1 meter. So we're going to end up with a moment of 200 Newton meters. And because it's anti-clockwise, we can go with positive 200 Newton meters. How about the man? Well, the man hasn't changed. It stayed exactly the same. So it's still going to be 100 newtons times by 6 meters. And that's going to give us 600 Newton meters. Or, considering the sign of that, we should put minus 600 Newton meters. So now to find our resultant, again, all we need to do is put these two together. Just add them up. So we've got positive 200 Newton meters. Take away 600 Newton meters. So overall, what's happening? This time we're ending up with negative 400 Newton meters. Now what does this mean? So we've got a negative sign now. Well, the negative sign, if we refer back to our initial directions, means that this here has an overall moment of 400 Newton meters in the clockwise direction, meaning that the man is this time going to tip the seesaw downwards. So there we go. Hopefully that's like a nice intro to resultant moments. Just some very, very simple stuff to begin with, just using little figures there. Here's one for you to practice. So pause the video and have a go at this, and then we'll have a look at it in a couple of seconds. Okay, welcome back. So this time, let's have a look at which way the seesaw is going to tip. Now hopefully you've set up two things. You've got anti-clockwise, which is positive, and you've also got clockwise, which is negative. And hopefully you've all spotted that the gorilla is creating an anti-clockwise moment. And I think this is a leopard, so we'll say the leopard is creating a clockwise moment. So just a couple of simple calculations then. For the gorilla, we'll be doing 880 newtons times by 4 meters. And that there, put it into the calculator, is going to give us 3,520 Newton meters. And that is in the positive direction, so we can put a plus sign on there, so positive 3,520. And then for the leopard now. So the leopard this time would be 620 newtons times by 6 meters. And overall that gives us a moment of 3,720 Newton meters. And because that is in the clockwise direction, we'll put a negative sign in front of it. So we've got 3,720 Newton meters. There we go. Now to find your resultant moment, we just add these two together. So positive 3,520 Newton meters, take away 3,720 Newton meters, and overall, hopefully, you've got a value of negative 200 Newton meters. And what does this actually mean? Well, it actually means that the leopard is going to cause the seesaw to tip downwards. Not what we would have expected, but there we go. That's how the calculation has come out. So hopefully you've understood all of those concepts mentioned in this video. A very, very simple intro. In the next video, we're going to be looking at one where there's no figures, there's just forces, they're just pivot points, and maybe some angles as well, who knows. So stay tuned, and thanks for watching. Hopefully see you in the next video.